Alright, so here's another identity that we are going to verify or prove. So we want to make this left side look like the right hand side just by doing some substitutions. And remember, I don't add or subtract anything from the left over to the right. I just think of this as like a wall. I'm not going to cross it. I'm just going to work on the left side and make it look like the right side. So notice that over here on the right side, what I'm trying to make it look like, there's no cosine squared anymore. There's just two of these things. That's a hint that what you're going to do is you're going to substitute something in for cosine squared to make it disappear. What we're going to use is the Pythagorean identity, that sine squared plus cosine squared is equal to 1. So I just solved this for cosine squared so that whatever I get, I substitute it in over here on the left side of the equation. So cosine squared is equal to 1 minus sine squared. So now I'm going to take that and substitute it in here. So I'll have sine squared beta minus 1 minus sine squared beta. And now distribute your negative sign through here, and I get sine squared beta minus 1 plus sine squared beta. And I'm pretty sure, since I've got two of these, that is equal to 2 sine squared beta minus 1. And it checks. Here's the next one. So notice I've got two fractions that I'm adding over here on the left hand side. Well, if I'm going to add two fractions, just go ahead and do that. And in order to do that, you need to get a common denominator. So the easiest way to get a common denominator is just by multiplying the two denominators that you already have. So on the left hand side, to make the bottom equal to cosine times sine, I need to multiply sine theta over sine theta, top and bottom. And I'm multiplying that times this original fraction, sine theta over cosine theta. Now, over here on the right hand side, to make it cosine times sine, I have to multiply cosine theta over cosine theta times the original one, cosine theta over sine theta. Now I've got two fractions. I'm going to keep the denominator the same, which is sine theta cosine theta. Up top, sine times sine is sine squared. And cosine squared times cosine squared, or cosine times cosine is cosine squared. And the Pythagorean identity tells us that sine squared plus cosine squared is equal to 1. And now I'll just break this up so it's really clear as to what I'm doing here. This is 1 over sine theta times 1 over cosine theta. 1 over sine is the same thing as cosecant. And 1 over cosine, same thing as secant theta. And you can see that that looks exactly like this, so we've done everything right. Checks out. Okay, got one more. I got tangent of gamma plus cotangent of gamma divided by tangent, trying to make that look like cosecant. So I'm just going to work over here on this side, and since this is a division problem, I'm just going to go ahead and divide this tangent into both of these to make that tangent gamma over tangent gamma plus cotangent over tangent. That is equal to 1 plus, and then cotangent over tangent. I'm just going to do some substitution like this. I'm going to make this cotangent over the reciprocal of tangent is 1 over cotangent. So I just substituted its reciprocal in there because I want to get this to be cotangent squared, which this is equal to 1 plus cotangent squared, and that is one of the Pythagorean identities, which is equal to cosecant squared gamma. So it checks out. The end.